Right, first we'll look at the vertical asymptotes, which sometimes can be the easiest to find. So that's when the denominator is 0. So we need to look for the values of x which would make the denominator equal 0. So these are when x equals 0 or when x equals 2. So what I've done to help us find the horizontal asymptotes is I've multiplied out those brackets. And then because we're dealing with x squared, so that's the highest power of x, I've divided each bit part through by x squared. Now because when we're dealing with the horizontal asymptotes, we're dealing at the extremities, so we're dealing when x tends towards plus or minus infinity. So when x tends towards plus or minus infinity, these fractions would tend towards 0. As the number on the bottom of the fraction gets infinitely large, the fraction itself tends towards 0. Leaving me with x squared over x squared, which is just 1, over x squared, which is just 1. Therefore, our horizontal asymptote is the line y equals 1. So, to find the coordinates of the points where the curve intersects the x-axis, you would set y to equal 0. Okay, so you can see y equals 0 now. If we multiply the denominator up, that would just disappear. So we're finding the values of x for which x squared minus 4x plus 3 equals 0. You factorise that, so you can see that the two solutions are when x equals 3 or when x equals 1. So they're the points where the curve intersects the x-axis. Okay, so here you can see the sketch of our graph. You can see that we've got the vertical asymptotes when x equals 0. And you can see we've got, so bear with me. Here is the asymptote when x equals 0. Here's the vertical asymptote when x equals 2. Here's the horizontal asymptote at the extremities, so when x tends towards plus or minus infinity, we've got a horizontal asymptote at y equals 0. And here we've got the crossing point when y equals 0, x equals 1. And when y equals 0, x equals 3, which link with these 2 points. Right, so it now says hence or otherwise solve the inequality. Now we're going to we always solve inequalities using graphs, so we're the hence part. So using the graph you've just drawn, we're finding the values of x for which our graph is less than 0. So in essence what we're looking for is these regions. So shade it on your graph, just shade the line a little bit so you can see. So for what value of x do I get that part of my graph? So this first region here, we can see this part of the line is when x is less than 1 but greater than 0. And both parts of that inequality don't have the equals 2 bit. The 0 part because this is an asymptote, and the 1 part because in the question it doesn't have the equals 2. So, and again this part, x has got to be greater than 2 because that's the asymptote, but it's got to be less than this crossing point 3. And again, 2 doesn't have an equals 2 part because it's an asymptote, and the 3 doesn't because it's not there in the question. If there had been an equals 2 part in this question, then both the 1 and the 3 there would have had the equals 2 part because they were crossing points, not asymptotes. Regardless of what inequality was here, these two would have never had the equals 2 part because they're asymptotes, and we know our graph can't cross an asymptote.